welcome to the Adobe lesson on polymers. Polymers can be both man-made and natural, and we break polymers into two groups, thermo-softening and thermo-setting. We'll deal with thermo-softening first. They can be reused, like the name says, they soften with heat. So as long as you heat it up, you can reshape them unlimited times. And the way we draw them for examination purposes is with long linear chains that look a bit like spaghetti. Now, to describe the bonds in these structures, we say they have strong covalent bonds along the chain, but have weak secondary bonds between the chains. Some advantages of thermo-softening is they're recyclable, chemically stable, easily formed into shapes, and have a smooth finish once they've been manufactured. Also, they're obviously corrosion resistant because there's no metal in them. Some examples: polyethylene, which is your common shopping bags, and polycarbonate, which is things like your bike helmets and the laminate layers in your windscreens of your cars and things. Now, before we get to these bits down here, we'll go over to thermosetting, the second type of polymer. Once we've set the thermosetting polymer, it's set for life. No matter how much heat or pressure we provide to it, it will just burn or char or just break down. The way we draw those in examinations is we still have the spaghetti-like structures, which are the chains, but this time we have cross-linking, little hooks going between them. And we say that's a heavily cross-linked structure. The difference between the thermo-softening chains is that these have covalent bonds along the chain still, but have strong covalent bonds between the chains. And these strong covalent bonds between the chains are what interlock it and make it set. Some properties of that: it has high heat resistance, chemically stable, corrosion resistance again, and have good heat and electrical insulating properties. Some examples: silicones, urea formaldehyde, which is what is nowadays used for your pot handles, melamine formaldehyde, which is Laminex, like on your kitchen countertops. You don't want those softening if you put a hot pot on them. And polyester resins, which make the modern day surfboard. And we don't want those going soft if you're in the surf in the sun. Now, these two types of polymers are manufactured in two ways: additional and condensation polymerization. Now, when those processes take place, we can also add additives, pigments to change the colours of the polymers, plasticizers to give them special qualities to make them more rubbery or softer, stabilizers to make them, if we're going to be using them in the sunlight, we don't want UV rays to break them down, so we have to add carbon black, and fillers, which just means that we're going to bulk them up using cheaper materials so we don't use the expensive oil-based primary product. And that is the revision for polymers for your examination. I hope that helps.